Okay, so for today's lesson, we are doing 4.02. I'm going to go ahead and give you guys the notes. You guys can get this worksheet from Google Classroom. And you're just going to watch the video, follow along. Once you're done with the notes, you'll be able to do the exit ticket, the journal pod 4.02. And then the homework for today's lesson is 4.02 evens. So we're doing today graphing and writing equations of cubic functions. So I'm going to help you review quickly how to do a sketch for the different type of functions and their domain and range. So the first one, this is an absolute value function because of the absolute value symbols. So remember that we have h and k here. So here is h and k. So that's -3, -4. And then a in absolute value functions, which is 4, that is the slope. So I'm going to go ahead and graph the vertex, which is -3, -4. That will be around here. And remember, this is just a sketch. And then the slope is 4, so it's really just 4 over 1. So you go up 4, you run 1. And then you can go up 4, back 1. And so here is my sketch. So the domain from left to right, what are the possible values? Well, it goes forever left, forever right. So that is -infinity and positive infinity. Range, lowest y value, highest y value. So your lowest y value is -4. And then it goes forever up. So that's positive infinity. And since it does go through -4, that's a bracket. And then for infinities, we always use parentheses. Next is y equals 1/2 x minus 3 squared plus 2. Because of the squared here, this is a quadratic function. And so let me actually write the name. So this is a absolute value function. This one is a quadratic function. And so in quadratic functions, we can see the h and the k. It's right there. That's the vertex, which is 3, 2. And then the a, this is not a slope. What the a tells us if it's wide or narrow. So if a is in between 0 and 1, your graph will look wider. If a is greater than 1, your graph will be narrow. So because this a is in between 0 and 1, and it's negative means it's gonna flip over. So first let me do the vertex, 3, 2. So 1, 2, 3, 1, 2. Here's a vertex. And then remember, usually quadratics face up, but because the a is a negative value, it's gonna flip down. And I'm just sketching it, and since it's between 0 and 1, I'm just going to make it wider than usual. So I'll just make it look something like this. It's just a sketch, so it doesn't have to be exact. So the domain for this, well, it goes from left to right. It goes forever to the left, forever to the right. So -infinity and positive infinity. And then the range, I have a maximum point here. That maximum y value is 2. And then it goes forever to the -infinity. It does go through 2, so that's a bracket. And then infinity is a parentheses. The next one, I have what we're learning, which is a cubic function. So this is a cubic function. And that's because of this cube here. So it's very similar to a quadratic function where this is what we would call the vertex. It's my locator point. And so that's 1, 2. So I'm going to go ahead and sketch that. So 1, 2. And then I have a 1/3, and it's similar to this information up here. So because a is in between 1 and 3, it's going to be much wider. And remember that cubic functions look like this. Let me erase that. They look like this. So because it's 1/3, it's going to be a little wider, but it'll look something like that. So I'm just going to make it wider. So domain left to right, well, it goes forever left, forever right. So it's negative infinity and positive infinity. And then range, it goes forever up and down. So it's the same, negative infinity, comma, positive infinity. All right. So getting into our guided notes for today. Suppose that we want to graph h of x. And so h of x is 3x minus 3 to the third power minus 4. So one way that we're going to simplify the graphing process is to create a table for the simpler but related function. And so the simpler but related function is basically ignoring the h and the k. So if I ignore the h and the k, I end up with h of x equals 3x to the third power. So I'm going to write h of x equals 3x to the third power. Remember, this is only to simplify the graphing process. So I'm going to create a table for that. Once I create the table, all I have to do is shift the points for the function. And so I'm going to move it 1 unit to the, this right here is telling me 1 unit to the right. So 1 unit to the right. And 4 units, this is telling me 4 units down. So 4 units down. So that's coming from h and k. Okay, so what I'm going to do is I'm going to create the table for this simpler version here. So I'm going to write y equals 3x to the third power. So if x is -2, then this is 3 times -2 times -2 times -2 3 times. So this is really just 3 times -8, which is -24. If x is -1, it's going to be -1. 3 times -1 times -1 times -1, which becomes 3 times -1, which equals -3. And then I do it when x is 0, so I replace the x with 0. And so this is just 3 times 0, which is just 0. If x is 1, then it's 3 times 1 times 1 times 1, which is 3 times 1, which is 3. And then if x is 2, it's 3 times 2 times 2 times 2, which just becomes 3 times 8, which is positive 24. So I'm going to graph these points, x and y, x and y, x and y, x and y, x and y. So the first one is -2, -24. So -2, -24 is about here. And then -1, -3, that is about here. Then I have 0, 0. Then I have 1, 3. And then I have 2, 24. And then I go ahead and connect the dots. And remember, I could have kept going, so I'm going to put arrows. I just decided to stop there. So right now, all that I have graphed is basically what I have in green, which is the 3x to the third power. Okay, so the next thing I'm going to do after I graph this function 3x to the third power, I need to do the transformations that I had ignored, which was 1 unit to the right and 4 units down. So basically, I just take these 3 points. I can take any. I'm going to take these 3 points here. I guess I'll take the 4 points, and then I'm going to move them 1 unit to the right and 4 units down. So if I move this point 1 unit to the right and then 4 units down, now remember this scale is going by tens on the y value. So if I go down, it's about here, 4 units. Same thing for this locator point. I go 1 unit to the right and then 4 units down, so it's about here. And then this one, 1 unit to the right, 4 units down, it's about here. And then this point here, 1 unit to the right and then 4 down. It's like this. So then I just connect them. And so here is my actual h of x. So it's this blue graph. All right, what's the domain and range? So remember, now I'm only paying attention to this one because this is the actual final graph that I have. The first one was just to be able to do the transformation and actually draw the final graph. So I'm only looking at that in blue. So the domain, well, it goes forever left and it also goes forever to the right. So the domain for this one is negative infinity, positive infinity. And then the range, well, what's the lowest value? What's the highest value? Again, it goes forever down and forever up. So negative infinity and positive infinity. Okay, another example. So I have k of x equals negative 2x plus 5 to the third power. So first, I'm going to create a table for the simpler but related function of, and I'm going to write k of x is equal to negative 2x to the third power. So I'm ignoring, for now, the h and the k. That's the only thing I'm ignoring. But this here, the negative 2x to the third power, is here. This is what I'm creating a table for. All right, so y is going to equal negative 2x to the third power. So if x is negative 2, then I'm going to have negative 2 and then negative 2 3 times. So that's going to be negative 2 times negative 8, which is positive 16. And then I do negative 2, negative 1 3 times. So that's going to be negative 2 times negative 1, which equals positive 2. And then negative 2, 0 3 times. So that's negative 2 times 0, which is just 0. And then negative 2 and x is 1, so 1 3 times. So negative 2 times 1. And then, sorry, what am I doing? Negative 2 times 0 is negative 2. And then lastly, negative 2 and then x is 2, so 2 3 times. So I end up with negative 2 times positive 8, which is negative 16. So I'm going to go ahead and plot these points. So I'm going to plot negative 2, 16. So negative 2, positive 16 is about here. Then I'm going to plot negative 1, positive 2. So negative 1, positive 2 is about here. And then 0, 0 is here. So 0, 0. And then 1, negative 2. So 1, negative 2, it's about down here. And then 2, negative 16. So 2, negative 16 is about here. And so remember, this is not my final answer. This is only to make the sketch of this graph much simpler. So then I need to go back and realize that this here, the plus 5, is a shift of 5 units to the left. And this minus 4 is a shift of 4 units down. So I need to do that to every point over here. So this point, this first point, I'm going to move it 5 units to the left. So 1, 2, 3, 4, 5, and then 4 units down. And then remember, the scale is going by 10, so it's not too much. And then I'm going to move this point 5 units to the left. 1, 2, 3, 4, 5. And then 4 units down, so somewhere over here. And then 0 is going to move 1, 2, 3, 4, 5, and 4 units down. So somewhere around there. And then this point, 5 units left. So 1, 2, 3, 4, 5. And then 4 units down. So somewhere around here. And then this point, 1, 2, 3, 4, 5. And then 4 units down. So somewhere around here. And so I'm just going to connect them to draw this here. And so there is my graph k of x. So this here is my final graph. Okay, so then what's the domain? Well, from left, it goes forever left, and it also goes forever to the right. So the domain is the same. Negative infinity, positive infinity. And for the range, it goes forever up and forever down, so it's the same. Negative infinity, positive infinity. And that's all. So next is your JunoPod activity. So with these notes, go ahead and do 4.02 JunoPod. So we did the notes, then do the JunoPod, and then submit your homework. This is found in Jupyter. And that is all.